this is the plan and document perspective. So partly the reason that we're doing this is in the past when we taught the class, and we get lots of nice comments about the class, and changed my life, and I got a job, and it's a wonderful intern. But there were people say, oh, I've done internships before. Nobody builds software. In the real world, they don't do it that way, right? And even on the MOOC, there were comments like, I would never use software built with Agile. This is crazy. This is this other way to do it. So what we thought, we'd let you know what the official alternative unit looks like, because if you become software engineers, you may do projects like this, and you need to know what these things are. Also, it'll help you see where Agile came from and appreciate what it's doing. So this will take a little bit of while to be able to do this. So they don't use user stories, points, or velocity. What do they do instead? And it's pre-Agile. And how do you make these costs? And how do you make these schedules? So these are all the steps. If you get to be the program manager, you're going to do requirements elicitation, requirements documentation, the cost estimate. You're going to be doing the scheduling and monitoring the progress of the project. You're going to do change management, kind of like version control, for your schedule, the cost, and the requirements document. You have to ensure that the implementation actually matches the features that were kind of in the contract, right, in the documentation. And then increase the chances that you'll hit this schedule, hit the target and the budget. You do risk analysis and risk management. So these are all your tasks to do. This will take a little while to go over. So let's do the requirements elicitation. So you're looking for both what are called functional and non-functional requirements. So functional is like we've seen, right? Add a movie to rotten databases. Non-functional would be, it's a kind of a weird word, but it's like about its performance. Non-functional, it's not features, it should be non-feature, right? Non-functional means 99% response time, less than a second, or 4 nines of dependability. So how do you elicit those things? Again, that has to come from the customer, and so it's pretty much the project manager primarily doing this. Project manager tries interviewing. You want to find out how the work is really done, not the way it's supposed to be done. Maybe you send a questionnaire to all the stakeholders to have them fill them out, or you just have these informal discussions. But you're trying to figure out how should this really be done, or how is it done today. You work with the customer, create these scenarios. You start off with the initial state. You show the flow for happy and sad paths, what can be done concurrently in the final state. Third approach is what's called use cases. And there's actually there's a language called the Unified Modeling Language that helps you describe these use cases where you have little stick figures and showing all the steps from the user and the system to achieve the goal. So these are ways for the product, user requirements elicitation. What does the customer want? After you've elicited the requirements, you do documentation, and this is serious documentation. It's called the SRS in the lingo, that stands for the Software Requirements Specification. These are big, hundreds of pages. There is even an IEEE standard on how to write an SRS. So you get a document that describes a standard about how to build this document. And remember, this is inspired by software doesn't work. We got to make it like civil engineering. Civil engineering has a lot of documents. We're going to have a lot of documents, right? And then, so how do you figure out if the SRS is okay? And I'll tell you the 4 things to look at. Well, the way you do it, get the customers to read these hundreds of pages and give you feedback, or you build a prototype that has some of the features to give you feedback, or you generate the test cases to test the SRS. And so what are you looking for here? 4 things. The validity, are all the requirements necessary? Consistency, that's pretty bad if the requirements conflict. Sounds like it'll be hard to be successful. Completeness, is everything there? And all the constraints included? And finally, can it be implemented, right? So you're building this kind of book about the project before you build the project. So that's requirements documentation. How about the cost estimation? So what the manager does is decompose these, the software requirement specification into tasks. You want, bind it a little bit like, points for user stories. You want to bound the task between 1 and 8 weeks. If it's more than 8 weeks, that's too big a task. Less than 1 week is kind of hard to schedule. So your manager is looking at the task, breaking up these pieces, then given the task estimates, you convert that into dollars via salaries and overhead. That's pretty straightforward. And then when do you do this? Well, you do it before you get the contract, and then after you get the contract, right? So you sure like those cost estimates to be similar, what I bid to get it and what it's going to cost the company to build it. So one idea is you add a safety margin. You and maybe you and your team work through how many weeks it's going to take to do these tasks, and you multiply by a number like 1.3 or 1.5. Another idea is you make 3 estimates. You make the best case estimate, the expected case, and the worst case. And then after you look at all those estimates, then you make your best guess. All right? That's the cost model that goes ahead. And now there's 2 kind of approaches to how to do that. One's called experiential, which is basically based on the program manager's experience and maybe the company's experience. This is what our guess is, how many weeks it'll take to do all these tests. But they were trying to make software engineering like civil engineering again, so they came up with quantitative approaches. The first approach was simply, let's estimate the lines of code of each of these tasks, calculate for the company the lines of code per person month, and you divide them and you'll get how many person months it's going to take. Well, the problem with that is lines of code, Bill Gates has a quote about lines of code being the wrong way to measure this stuff, so that didn't work very well. So the researchers decided we're going to measure a bunch of projects, we're going to come with a better quantitative model, and they call it the COCOMO model, constructive cost model. And it's got 2 factors and an exponent, and so they looked at a bunch of projects, and here this is the 3 significant digits, right? I think the average is going to be 2.94 to the times the code size and lines of code to this 1.23 penalty with a product factor of 1.07, right? You multiply that together, that'll tell you how much effort it is, put that in the cost budget. So the guys who came up with COCOMO, so that didn't work very well, so they came up with COCOMO 2, and it had 17 factors, right? So the software is getting more sophisticated over time, and they're trying to, we can make this quantitative, I know, if we just try hard enough. So not surprisingly, the survey says 92% of the time, the customer just relies on their experience to make this model. Okay, that's the cost estimation. What about scheduling? So what you're trying to figure out is what tasks you can do in parallel. And you may have heard of PERT charts. So let me show you what a PERT chart is. It was it was developed in the aerospace industry to figure out how long it would take, or in the space, how long it would take to build a space shuttle. So each of these nodes are milestones. So these little rectangles, there's 11 milestones for the project, all right? And then these names that are on these arcs say what's being done. So this is requirements elicitation. And then what these little numbers are on the arcs are how much effort it is, say person weeks, for example. And then the arrowheads indicate dependencies. So one reason that people made PERT charts is to figure out what's called the critical path, is given all these arrowheads, what's the longest, the shortest time, no, the longest time through this effort till we get to the final milestone. And in this example, here's the critical path. So you just divide up all the efforts along those lines that tell you, and then some kind of productivity factor, and tell you how long it would take to do the project. And it could show you what things you can do in parallel. So if you're the project manager, you did the SRS, you break it into tasks, you get it into costs, and then you use those to create the schedule using something like PERT charts. Now that you've made a PERT chart, what do you do while the project's going? Well, now you want to compare what you predicted to how long things are taking, and so you track both the actual expenditures and the time for those tasks, maybe against your PERT chart. And what they found is that by sharing these intermediate milestones, there were 11 milestones on the slide, everybody is aware of whether you're on budget or on schedule or not, both the people building it and the customers. Okay, so this is, can you build it in time, and on budget, but you're not done as project manager. Does it actually do what you want, what the customer asked for? And this is called requirements traceability. So there's tools that are developed to try and tie in all these pieces together. The software requirement spec, what piece of the software requirement spec is associated with the piece of code that implements it, which is associated with the tests that validate that. So by having these tools to keep those together, you can ask yourself, well, did we really implement everything the customer asked? Well, let me go in and test. Is it passing that test? Well, good, because then it's handled that piece of the requirement. So are all the pieces of the 100-page document covered with tests and the corresponding code in the SRS? And then if the code changes, you want to go back and test that. Now, to try and increase your chances of hitting the target, there is, borrowed from the business school, is risk analysis and management. So basically, you're trying to make this more accurate. So you're trying to guess what the risks are going to be before you do it. And so what do you do if you identify a risk? Well, you can do extra work to reduce the risk, do extra work to prepare yourself, or change your plan so that risk goes away. So a technical challenge, hey, the relational database won't scale to be big enough. Well, maybe we could find a bigger machine with a bigger relational database so we can make that risk go away. Boy, our organization isn't familiar with J2EE, which we have to use to build that. What can we do to mitigate that risk? We could send them to, we could take tutorials, online tutorials to get them better at J2EE so that risk is mitigated. Oh boy, the business risk is it's going to be too late for the market. Well, maybe we should cut back the features so we can get it in the market in time so that it'll be viable, right? Or you know, if it's really bad, then we shouldn't do this at all. So, boy, you can imagine, you're guessing the risks. So what's the advice you should do? Well, try and you guess what the risks are, make your best guess of the chances of this risk happening, and then on your own 10-point scale, give it an impact factor. Boy, if this thing happens, how bad it'll be for the project. And then you multiply the chance times the impact factor, and you come with a number, and you sort your risk by that, and then you tack the top 20%, and you're hoping that that's most of the risk. And so the risk analysis is trying to hit you on schedule. So these are all the things you need to do as a manager, and we put this side by side in the table, which you may be able to read. So here's the 7 steps on the left. So the requirements, documentation, elicitation, change management, schedule budget, ensuring requirements features, scheduling and monitoring, that's all that corresponds to user stories, points, and velocity, right? So user stories, points, velocity, which I just talked about in the last couple of segments, is, you know, relatively intuitive. Boy, this is what that replaces, right, for Agile. And then the cost estimation is this kind of loosey-goosey thing we talked about. Instead of trying to hit it and promising it, delivering features, and doing extensive risk management to make it more likely, well, you're saying you're doing it on a best effort approach. Okay, so that's what it means. That's the alternative universe here that many of you, a lot of people do use for lots of projects, and you may do yourself, that helps you to see what's different about Agile.